So today our main goal is to still graph radical equations. We're going to add on a new skill of writing transformations of radical functions as well. So in the core concepts, I went ahead and just again gave you some review about what basic transformations we have. So the first one it lists is the horizontal translation. Remember, horizontal translations are either inside the parentheses with x, or in this unit, it's going to be under the radical with x. So if I see something like this, where I've got the square root of x minus 2, that's going to be a shift 2 units to the right. And if you see x plus 3 underneath the radical, that would be a shift 3 units left. I also put in a column over here that describes how you would change the key points and the parent points. So if you have a shift 2 units to the right, in your XY chart, you're going to take whatever that x value is and add 2 onto it. If you have a shift 3 units left when you're doing your XY chart, you're going to take whatever your x value is and you're going to subtract 3 from it. Okay, so this is a nice description over here to the right on how you change those parent points. Vertical translation, that's up or down. And we see a plus some number or minus some number at the end of the function. So if I see plus 7, that's going to be 7 units up. It's changing your y value there. So in the xy chart, you take whatever your y value is and add 7 onto it. Get it to go up. Minus 1 is going to be 1 unit down, so you take your y value and you would subtract 1. Reflection depends on whether the negative is inside the parentheses or outside the parentheses. Right? If the negative is inside the parentheses or under the radical, that's going to be a horizontal reflection. Horizontal reflection is also known as a reflection in the y-axis. Horizontal reflections change the x value. Right? So if you see a negative inside the radical, you take your x value and you multiply by negative 1. The little star is just multiplication. If you see a negative outside the radical, that's going to be a vertical reflection or a reflection in the x-axis. They mean the same thing. In which case, you would take your y value and you would multiply by negative 1. Horizontal stretch or shrink. What's the key word for horizontal stretch or shrink? Reciprocal, right? So if I see 3 times x inside the radical, we know it's a horizontal stretch or shrink because x is being multiplied by a number. We have to use the reciprocal of 3, 1/3, in order to determine if it's a stretch or shrink. So because the reciprocal of 3 is 1/3, that's a number that's between 0 and 1, right? It's less than 1, but greater than 0. So that's how I know it's a shrink. Bless you. If we have something like this, where we have 1/2 x underneath the radical, the reciprocal of that would be 2. Because this factor is bigger than 1, that's how I know it would be a horizontal stretch. So what do I do in the xy chart? Whatever my x value is, I'm just going to multiply it by the reciprocal of the number that's listed here under the radical. You'll notice a trend that anytime it's a horizontal change, or multiplying or adding or subtracting something from the x value, whereas if it's a vertical change, you're going to be adjusting the y value. Vertical stretch or shrink, that has to do with this number out front. You just take the y value and you multiply it by whatever that number is out front. If the number is bigger than 1, it's a stretch. If the number is between 0 and 1, it's going to be a vertical shrink. So, bigger than 1, stretch. Less than 1, but greater than 0, shrink. All right. So let's go ahead and just review the parent functions. We've already talked about these last class. Our main focus is going to be on square roots and cube roots. So with square roots, we developed this XY chart last class. -4, if you plug that into the square root function, can you take the square root of a negative number? No, right? You cannot take an even root of a negative number. which is why we got no real solution when we plugged in both of those negative x values. So really, those aren't the important points because they're not going to be graphed at all. You're not going to see it on a real number graph. This is the important stuff right here. If I take the square root of 0, I get 0. If I take the square root of 1, I get 1. If I take the square root of 4, I get 2. Okay, those are my parent points. I'm only going to require you to use 2 of these parent points. So we're going to say that the key points or the parent points that we're going to use most common are 0, 0, and 1, 1. Just because I definitely want you to have 0, 0, and then you have to have one additional parent point. So whether that's 4, 2, or 1, 1, I don't care. It's just oftentimes 1, 1 is an easier point to use. So that's why I gravitate towards 1, 1 as opposed to 4, 2. All right, so I've got 0, 0, 1, 1, 4, 2. This is what my parent function looks like for square root. All right, my domain is going to be that my x values have to be greater than or equal to 0. Again, can you take a square root of a negative number? No, right? So my x values either have to be 0 or bigger. Because if I take a square root of a negative number, it would be no real solution. Also, you can see from my graph that my starting point is at 0, 0. So everyone see how my starting point is 0, 0? So the lowest x value I'm going to use, I'll write x a little bit different. This is x comma y. My smallest x value is going to be 0. Okay, and then it's just going to increase from there. Same thing with my range. My y values would also have to be greater than or equal to 0. Again, if you look at your graphs, bless you, you can see that your lowest y value is 0. Okay? There's no graph happening down here. So a graph starts at 0 and then is above 0. So that's why your y values have to be greater than or equal to 0. That's going to be your lowest y value. Any questions on the square root parent function? Okay. We also have the cube root parent function. Last class, we talked about developing some key points for that. If I take the cube root of 8, I get negative 2. If I take the cube root of negative 1, I get negative 1. If I take the cube root of 0, I get 0, etc. Okay? Any x value that we plug into a cube root, it's possible to get a corresponding y outside. See how there's no restrictions on what x values you can plug in? You can plug in positive x values, 0. You can even plug in negative x values, right? It's possible to take an odd root of a negative number. That's fine here. Okay, for the key points, I'm just going to require you to use 3. I want you to use one of the negative x values. I want you to use 0. And I want you to use a point with a positive x value. Okay, so you need to have a point with a negative x value, 0, and a point with a positive x value. So oftentimes, the easiest points to pick are negative 1, 0, 0, and 1, 1. If you want to exchange out negative 1 for negative 8, negative 2, fine. If you want to sub out the positive 1, 1 for a positive 8, positive 2, fine. Okay, but I need to see at least one negative x value, 0, and one positive x value. Okay. If I graph this, I'll have a point at negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and positive 8, positive 2. And your graph looks something like this. Are there any restrictions on what x values you can plug into a cube root? No, I can plug in any x value. Okay. So the domain is all real numbers. Also, keep in mind that this graph is going to just keep going infinitely to the right and infinitely to the left. So my x values are all going to be used, right? Towards negative infinity and infinity. You don't need to put in these extra little dot, dot, dot. I just wanted you to be aware that it's going to keep going infinitely in both directions. So all your x values will be used. Similar to that, we'll have all real numbers for the range as well. Again, the range are your y values. So even though it's kind of hard to tell in this picture, as my x values get smaller and smaller and smaller, my y values are just going to continue to decrease infinitely. Kind of hard to tell because it's not a drastic change. But the smaller my x values get, the smaller and smaller and smaller my y values are going to get. And as my x values continue to increase or get bigger, this graph is ever so slightly going up. Okay? So all my positive y values will also be used, which is why the range is all real numbers. Any questions on that parent function? All right, here's my first example. We're going to list the transformations, we're going to identify 2 points, and then write the domain and range. Notice that your homework or classwork, you'll get to kind of work on this in class, is very similar. See how it has 2 points, colon, domain, colon, range, colon. Everyone see that on their homework? 2 points. The 2 points I'm referring to are not the 2 points of the parent function. I want to know the 2 or 3 points after the function has been transformed. Okay, so for all of these, you'll do an XY chart with the parent function, transform the points, and then list those 2 transformed points. Okay? So here, my transformations would be, let's see, what does the x minus 3 tell you to do? Write 3. Okay, so we have a translation. Write 3. And then what's the plus 4 tell you to do? Up 4. Okay, so we have a translation, write 3, and up 4. So what I'm going to do is write my XY chart over here. And think about what parent points I need. This is a square root function. So the square root is not going to have the negative x values, right? It's only going to be 0 and positive. So I'm just requiring you to use 2 points. So I'm going to use 0, 0, and 1, 1. You could have used 0, 0, and 4, 2. So you just need to have 0, 0, and then one of your positive x values and corresponding y outputs. So write 3 up 4. For write 3, I'm going to add on 3 to my x values. Right? Write 3 is a change in x. So 0 plus 3 is 3. 1 plus 3 is 4. And up 4, change in my x values or change in my y values? Y. Okay, this is a change in my y values. And so my y values, I'm going to put plus 4. 0 plus 4 is 4. 1 plus 4 is 5. Oh, that's okay. I thought I made a mistake. I was like, what? That's fine. Okay. Any questions on this? All right, so the 2 points I'm going to list are 3, 4, and 4, 5. So we've got 3, 4, and 4, 5. So this is what my graph's going to look like. That's my new function. For all of these, I'm not requiring you to draw in the parent function. I think that's redundant. The parent function, you should know that the parent function has points of 0, 0, 1, 1, and 4, 2. I'm not requiring you to draw that in, but it is a good exercise to think about whether or not the transform function that you drew makes sense. Does this function that we drew in make sense? If I take my parent function and shift it right 3, 1, 2, 3, and up 4, is this starting point going to land on my new starting point? Yeah. Okay. You just want to make sure that the graph you draw makes sense with the transformations you were given. Domain and range. My starting point here is at 3, 4. Does everyone agree that that's my new starting point? So if I want to know what my starting x value is, what is it going to be? 3, right? My first x value is 3, and then my x values are only going to increase from there. Okay? So with domain, my x values are either going to be greater than or equal to 3. For my range, what is my lowest y value? My starting point's at 3, 4. So my lowest y value is 4, right? And then my function only goes up from there. See how it starts at 4 and then goes up from there? So I'm going to say that my y values have to be greater than or equal to 4. Any questions about that? Second example, transformations. We've got a negative underneath the cube root. What does that negative do? What? It's a horizontal reflection. Okay? Or you could say a reflection over the y-axis. They're the same thing. So this is going to be my horizontal reflection. And then what's this 8? What does the 8 do? What kind of transformation? X is being multiplied by 8. Say it loud. It is a shrink. What kind of shrink? Horizontal shrink. Very good. So anything under the radical is going to be horizontal, right? Anything outside the radical is vertical. So we've got this horizontal reflection. Or you can say that it's a reflection over y, the y-axis. Okay, and we also have a horizontal something by the reciprocal, which is 1/8. Okay, that's what I do. I always write the reciprocal first, and then I identify if it's a horizontal stretch or shrink. So if 1/8 is a number that's less than 1, so bigger than 0, is that going to be a stretch or a shrink? Shrink, okay? If the reciprocal was bigger than 1, it would have been a stretch. And so it's a horizontal shrink by 1/8. Okay. All right, so now I'm doing my XY chart. In this case, I have a cube root. Actually, I'm going to do my XY chart down here. Okay, so again, I'm only requiring you to use 3 points. With a cube root, do you want to put negative x values? Yes. With a cube root, you want to have 1 point that has a negative x value, 1 point that has an x value of 0, and 1 point that has a positive x value. Just so that we can get both sides of the graph. Okay, so my parent points, if I take the cube root of -1, I get -1. Cube root of 0 is 0. Cube root of 1 is 1. Okay, so there's my parent points. Now, I'm going to do a horizontal reflection over y. What is that, a change in x or a change in y? If it's horizontal. X, right? This first one's going to be a change in x. So I'm going to change all my x values. If I change all my x values, I would be multiplying them by -1 for the reflection. So this would become +1, 0, and -1. Then I have a horizontal shrink by 1/8. Again, it's horizontal, so that's going to change my x values. All right, there we go. So change my x values again. This time, for horizontal shrink by 1/8, I'm going to be multiplying all my x values by 1/8. So multiply by 1/8. 1 times 1/8 is 1/8. 0 times 1/8 is 0. And -1 times 1/8 is -1/8. Any questions about that? Now, all those points are going to be super close together, right? 1/8, -1. That's really, really close to that y-axis there. 0, 0, and -1/8, +1. So that's going to be right here. See how close all those points are together? This is the only time where it might be good to use the parent point -8, 2. I'm sorry, -8, -2, and +8, +2, so that you can get some points that are a little bit further away from that y-axis. So I'm requiring you only to do 3 points. But if you get a graph that looks like this, where all of them are really smushed together, if you want to write in some bonus points, you can start with the -8, -2, and +8, +2, and do the same transformations in order to get some points that are a little bit further away, so you have a better idea of what the graph looks like. Here, if I were to multiply both of these by -1, this would become +8 and -8, and then multiplying those by 1/8. What's 1/8 of 8? 1, right? If I multiply something by its reciprocal, I get 1. Okay. 1/8 times 8 over 1. 8 divided by 8 is 1. Right? So here I get 1 and -1. With those points are a little bit nicer to plot. You'd also have a point at 1, -2, and -1, +2. Yeah, they're just a little bit further away, so it's not all smushed together. Again, you want to make this a nice curvy shape. Do not just put a line through it. I see people sometimes when they're graphing this, they just connect all the points and they go, okay, there's my graph. This is not a linear equation. So do not just draw a line through it. That's wrong. Okay, you want to have some curvature to your graph. So under my 3 points, I'm going to list the 3 points. 1/8, -1, 0, 0, and -1/8, +1. If you want to list the bonus points, you can. We also found the point 1, -2, and -1, +2 to help us graph it. But I'm only requiring 3 points for the transformation. So my domain and range. This is an odd root. What is the domain and range for odd roots? All real numbers. The x's are going to extend infinitely outward, and my y values are going to extend infinitely up and down. All right. Any questions on that example? All right, example 3, we've got our transformations again. Got a negative out front and a -2 out back. What do you think the negative out front would be? Vertical reflection, very good, or a reflection over the x-axis, same thing. And then the -2 out back, that's going to be a shift down 2. All right, so my transformations are a vertical reflection, or you can call it the reflection over the x-axis. They're the same thing. And a translation down 2. Order does matter, so we just want to make sure we're always reading our function from left to right. Okay, when you list the transformations, read your function from left to right to make sure you're doing it in the proper order. Hi there. Also, think about order of operations. When you do a vertical reflection, aren't you going to be using multiplication? Right? Whereas a translation down 2, you'd be using subtraction. You always want to do your multiplication and division before addition and subtraction. Okay, so even with order of operations, it makes sense. Okay, so let's go ahead and make our XY chart. This is a cube root function, so do you want to put a negative x value in your XY chart? Yes, you want to make sure that you have that represented. So I'm going to use -1, 0, and 1. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. So now we have a vertical reflection. Is that changing my x values or my y values? Vertical, think up and down. Y, right? So this is changing my y values. And the translation down 2, moving something down, that's also going to change my y values. So we're changing both of our y values. Okay, so vertical reflection, I'm going to multiply all my y values by -1. So we have +1, 0, and -1. Translation down 2. We're going to take all of those y values and we're going to subtract 2 from it. Again, I did the multiplication before the subtraction. 1 minus 2 is -1. 0 minus 2 is -2. -1 minus 2 is -3. Okay. Any questions about that? So here's our 3 points. We get -1, -1. That's the calibration's off here. We get 0, -2. And we get 1, -3. Okay, we'll graph that over here. -1, -1, 0, -2, and 1, -3. Again, am I just going to go like this and put a line through this graph? No, this is not a linear equation. You got to put your curvature in here. So it's going to come like this, curve down, and come back around that way. Any questions about that? What are the domain and range for an odd root? Is there any restrictions on the x values or the y values? There's really no restrictions. Okay, so I see an odd root, I immediately think all real numbers. Any questions about that? All right, cool. So the new learning goal today is writing the equation of a transformed function. So an example 4, the first example says, let the graph of g be a horizontal shrink by a factor of 1/6, followed by a translation 3 units to the left of the graph cube root of x. Write a rule for g. So my starting point is this cube root of x. We're going to do one transformation at a time. So I want to see multiple steps. Step 1, it says let g be a horizontal shrink by a factor of 1/6. Anywhere you see horizontal stretch or shrink, what are you immediately thinking? Reciprocal, right? Keyword, reciprocal. So for anything horizontal, remember we replace x with something inside parentheses, right? With anything horizontal, we're going to replace x with something inside the parentheses. I just put scribble inside the parentheses, okay? So here we're going to replace x with something new inside the parentheses. The reciprocal of 1/6 is 6/1. So we're going to replace x with 6x. That's my first step. Okay, so where we saw this x before, we're not going to have x anymore. We're going to replace x with something inside the parentheses. So see how we plugged in 6x or x's? All right, so simplifying that, I really don't need the parentheses in this case, so I'm going to simplify that. Okay, the next step, it says followed by a translation 3 units to the left. Is that horizontal or vertical? Horizontal, so something inside the radical is changing, right? So 3 units to the left, that's horizontal, so again, horizontal. Your wording is replace x with something inside parentheses. Replace x with something inside parentheses. How do I express left 3 using a function? How do you know when you look at a function that it's left 3? What do you see inside those parentheses? X, is it plus or minus? Plus, right? 3 to the left is going to look like x plus 3 in an equation, right? If you see an equation, that's how you know to do left 3. So this is where it gets a little bit tricky. See where I have this x? What am I replacing x with? Parentheses x plus 3. Anytime you use substitution, you've got to put it inside parentheses. Okay, now that's very important because if I were to distribute the 6 through, that's going to be 6x plus 18, right? Totally different than 6x plus 3. Hold on one moment. My computer froze. All right, so like I said before, you got to be careful here because if you don't put this in parentheses, this x plus 3, you're not going to get the right function at the very last step. I just want to make a point of saying that these two expressions are completely different. The one in the red is wrong. The one in the green is correct. And you need to put parentheses around your x plus 3. Because when I distribute that 6 through them, I'm actually going to end up with 6x plus 18 underneath that cube root. Either one of these are fine for your final answer. We just want to make sure that we label our final answer g of x. G of x equals the cube root of 6x plus 18. Or you could put 6 times in parentheses x plus 3. This is our second grade solution. Any questions about that? The process? We're going to do one more with vertical shifts. It says let the graph of g be a shift down 2 units followed by a vertical shrink of 1/2 of the function square root of x minus 8. Write a rule for g. Okay, so we're starting with this function square root of x minus 8. That's our starting point. The first thing I want to do is shift it down 2. Remember, anything vertical happens on the outside of parentheses. Anything vertical, we're either going to have something out front or we're going to have something out back, right? But either way, it's happening outside the parentheses. So if I want to shift it down 2, we're going to take whatever our function is, and I'm just going to subtract 2 from the end. It's not multiplication. All I'm doing is subtracting 2 from 8. So really you can see how a shift up or down, you really don't need to put the parentheses in the problem. So this would be, oops, I accidentally put a negative in there with it. That's not right. All right, so I have the square root of x minus 10. Right, that would be my shift down 2. I'm just subtracting 2 off the end. Then it says followed by a vertical shrink of 1/2. This is where it gets a little bit tricky. If I want to have the entire function, right? I want to take whatever half of this function is. What do I need to ensure that I take half of the entire function? Parentheses. If I don't put parentheses around that entire function, I'm only going to be having the first term. But I don't want to just have the first term. I want to have both terms. So anything vertical is going to go outside of those parentheses. Square root of x minus 10. You want to have both parts. Distribute the half through both parts, so you get 1. All right, we would end up with 1. Standing too close to my board. All right, we get 1/2 times the square root of x minus 5. So that's going to be my final answer for g of x, right? Is that what they told me to name it, was g of x? Mm-hmm. Okay, so we get 1/2 the square root of x minus 5. That's my function. See how I'm doing this in multiple steps? I don't want you to try to do all of it in one step. Do the first transformation, simplify. Do the next transformation, simplify. And then just name it g of x or whatever it tells you to name it at the end. All right, so we still have about 15 minutes left in here. If you want to work with someone else, you can. But you're working through the 5.3 day 2 practice worksheet. I need to see XY charts for every one of these. I need to see XY charts for every one of these. Later in the year when we get to sine and cosine and tangent function graphs, you're going to be thankful that you had so much practice with the XY charts. Because those can be kind of complicated. All right, that's it. Is that going to be our next chapter? No, we won't get there for a little while, but all this is practice just leading up to it.